We need to pay a lot of attention to barrier busting. There are 60 or 80 specific market failures in these categories in buying energy efficiency. There are proven ways to turn each one into a business opportunity. These are laid out in the implementation lecture I did at Stanford last year and in this 11-year-old publication on our website. And I think barrier busting should be at the top of the policy agenda and businesses' energy strategy to turn these stumbling blocks into stepping stones. My last thought for you today is about major process industries. There's another whole set of issues in buildings, but here are the sorts of things I often observe that as managers you should know about. Quite often things were designed as if fuel is free, and one department makes the investment to reduce the fuel and another gets the benefit. We're very bad at measuring things, and I might say particularly in Singapore, we're rather deficient in measurement to keep improving the design, improving our practice, sharing it company-wide. I've seen companies here that lose millions just by not sharing their own best practice between their own plants in Singapore. In complex industries like petrochemicals, there may be a big, bookshelf of design manual, and you'd really have to blow it up and start over to fix it because it's so interlocked. No one really has the stomach for that. The operators are often stretched thin. They're too busy to think about anything beyond keeping the plant working safely and properly. So efficiency is, job 11 and never quite happens. Most firms in all sectors ration capital in an odd way. They grossly underinvest in some of the lowest risk, highest return investments available, namely energy efficiency. And they often will run their cash flow allocation with discounted metrics quite properly, but then tell the operating engineers to meet a 1 or 2 year simple payback criterion without telling them how to translate between the two. And then you get them together and show the Rosetta Stone, and the engineer says, oh, I could do a 7-year payback and still meet your hurdle rate. Why are you telling me to do 1 year? We're cheating the shareholders. So we really have to get the metrics together. And we have to remember that saved overheads go directly to the bottom line. Even if energy is only 1 or 2% of your cost of doing business, it can have a big influence on earnings per share. We tend not to collect the right information and get it to the right people. I can think of only 2 chip fabs in the world where there's a long enough straight run of main chilled water pipe to put in an accurate flow meter. This meant there was never an intention to measure how much energy it's taking to make a unit of chilled water because we never intended to make it better. Particularly in Singapore, there's a lot of risk aversion. The Kielce mentality is rather well entrenched, and it means that the engineers don't have an appetite for intelligent risk-taking. They have plenty of intelligence, but they're a bit timid because they don't feel they'll get support. Maybe you should give a Goof of the Month prize. Seriously, rewarding the best intelligent risk-taking so that people see it's okay to step forward and try something new. And I think most of all, as managers, we need to see integrative design and energy efficiency directly and indirectly as a huge new source of competitive advantage for your firm and for the country. There are obstacles to doing what I've described. We have a very risk-averse culture in semicon, and understandably so. It's really hard. But why are we only innovating inside the clean room? Why does total quality management stop at the clean room wall and not extend to how we provide chilled water and clean air? Is any fab in the world optimized for its climate? I have yet to see one. There are often kind of tribal behaviors between the process staff and the utility staff. They address each other perhaps in 4-letter words. It's always their fault, and they seldom cooperate properly. Nobody in the system owns energy losses or gets rewarded for reducing them. And there's never a good time to design for efficiency because either business is good and then, your pants are on fire and you're trying desperately to get the next fab online to get to market quickly and you can't think about anything new, so you copy the last set of drawings, or business is bad, our engineers are beached, there's nothing on the drawing board, so we can't really justify the budget of taking the engineers we've already got that aren't doing anything and paying them to think about the next fab or the fab after next, which would be the right time to do it. Well, Paul Westbrook at TI managed very artfully to squeeze through the invisible crack between these two conditions. That's how he got those breakthrough results. And in the cyclic business, I hope some of you will grasp that opportunity. The key data are seldom measured or displayed. There's only a handful of fabs in the world that can or do accurately measure chilled water kilowatts per ton. Most of them don't have a sufficiently long, clear length of main chilled water pipe to do an accurate flow measurement. What this tells us is that doing that measurement was never part of the design intent because we didn't intend to make it better in the next one. That's a pretty serious indictment. And we often forget that saving even a little bit of total cost matters, because like any saved overhead, it drops to the bottom line. And often, basic energy efficiency will add 1 percentage point or more to your total net profit. Think about it this way. If selling new chips earns 10% profit, saving $1 worth of energy raises your profits by the same amount as selling $10 more of new chips. And it's much harder and less certain to do that than to save energy that's entirely under your control. There's no competition in doing that in your plant. And if you're short of capital in the chip business, please don't waste your capital on oversized and overcomplex utility plant.